Okay, so what if I told you that the very light bulb lighting up your room right now could be streaming this content to your device? It sounds like something straight out of a sci-fi movie, doesn't it? Well, today we're going to dive into the technology that makes that whole idea a reality. So, let's just start with this one simple question. What if that ordinary desk lamp could do more than just, give you light? What if it could also be your key to a secure, seriously fast internet connection? And that brings us right to our first topic. What in the world is Li-Fi? You might hear it called light fidelity. So, at its core, Li-Fi is a wireless communication technology that's, well, it's both brilliant and simple. While the Wi-Fi you and I use every day uses radio waves to send data, Li-Fi uses the visible light from LED bulbs. It's kind of like sending a message with a flashlight, but on a scale that's way, way faster and a whole lot more sophisticated. And this right here is a huge shift. I mean, for decades, our entire wireless world has been built on radio waves. That's your Wi-Fi, your Bluetooth, your cell signal. Li-Fi moves everything over to a totally different part of the spectrum, visible light. So why does that matter? Well, the visible light spectrum is thousands of times larger, which means there's just a lot more room for data to travel. Okay, that sounds awesome in theory, right? But how does it actually work? How do you send something as complex as a video through a simple beam of light? Let's break it down. So, this diagram, this gives you the whole picture from start to finish. You've got data flowing from the internet, going through a transmitter that's hooked up to an LED lamp. Then the light from that lamp carries the data to a photodetector on your device, which turns it back into information you can actually use. Now, let's unpack each part of this whole process. So how do you actually get data out of a light bulb? Well, the secret? It's all in the flicker. See, a special LED bulb acts as a transmitter and it flickers on and off millions, even billions of times every single second. Now, this flicker is so incredibly fast that our eyes can't see it at all. To us, the light just looks constant. But for a receiving device, this super fast flickering is basically a language. You can think of it just like Morse code, but with light. When the LED is on, that's a 1. When it's off, it's a 0. And by sending these ones and zeros incredibly fast, you can transmit any kind of digital data you want, from an email to a high-definition movie. So how fast are we talking here? Is this just a cool party trick? No way. The potential data rates can reach hundreds of megabytes per second. That is a seriously fast connection, and it's all delivered by the light in the room. Okay, so let's put it all together one more time. Step 1, a transmitter takes your internet signal and uses it to modulate the LED's current. Step 2, the LED flickers like crazy, sending that data through light. Step 3, a photodetector on your laptop or phone catches that flickering light. And finally, step 4, the receiver circuit amplifies and decodes that signal back into data your device can understand. It's really just a seamless 4-step dance from internet to light and back again. Okay, so we get the process. But what's the actual hardware behind all this? What are the key pieces of the puzzle that make a Li-Fi system work? It really just boils down to 3 essential parts. First, you've got to have those specially equipped LEDs to actually send the data. They're the source of the light. Second, you need a photodiode. That's a component that actually detects the light and converts it into an electrical signal. And third, you need the light sensor and all the processing circuitry to receive and make sense of that data. Simple, but incredibly effective. And why is this technology so exciting? Well, this quote from our source material really says it all. The reason Li-Fi has such immense potential for speed is because the visible light spectrum is 10,000 times wider than the radio frequency spectrum that Wi-Fi has to use. That's like going from a single-lane country road to a massive multi-lane superhighway for your data. So we've basically figured out a way to use the lights that are already all around us for super fast internet. It's more secure too, since light can't pass through walls, and it won't interfere with sensitive radio equipment. This just raises a fascinating question. With data literally traveling at the speed of light, where is this technology going to show up next? Our homes, our offices, maybe hospitals, or someplace we haven't even imagined yet?